Okay, so welcome to the webinar. This is being put on with Canadian Water Resources Association and Canadian Society for Hydrological Science. I'm Robert Chlumsky. I'm organizing a little bit here today. I'm a water resources engineer with the Ecosystem Recovery, and I'm also part of the CSHS Hydrology Group, which is working on putting together an R package for Canadian hydrologists. We have with us here today Sam Albers. He's a data scientist with the BC government. He's a graduate of University of Victoria and also of UNBC, that's University of Northern British Columbia in Prince George. He's the author of the Tidy HYDAT package, as well as a co-author of the WeatherCan package, which we'll talk a bit more about today. And he's an expert in our data scraping, data analysis, and knows a lot about building packages in R. So we're quite happy to have him here sharing some knowledge with us today. In terms of logistics with the webinar today, everybody will be in basically muted, but you can still communicate, ask questions, and interact through the questions and the chat, which hopefully you can see in the GoToMeeting window in front of you. And if you do have any questions, just please feel free, and I will periodically interrupt Sam to make sure that your questions get through. All the materials and the webinar itself is being recorded, and they'll be made available afterwards to all the registrants. So even if someone didn't get it as part of the 100-person cap for the live webinar, you can still view the materials afterwards. So you can let your colleagues and people in your network know about that if they're interested. And I think with that, without further ado, I'll turn it over to Sam.
Great, thanks, Rob. Hello, everyone. It's great to be here. It's definitely a privilege to present to this group, and hopefully I'll be able to kind of get you excited about R and sort of demonstrate some of its usages. So just a quick outline. I'll just, although Rob did a pretty good job, I'll just tell you who I am. I'll kind of try and talk about what I'm hoping to convey today, sort of in the form of some learning outcomes. Reasonably ambitious sort of set of things that I want to do, but hopefully we'll be able to cover them. So just to sort of get a somewhat of a baseline for folks, I'll start with reviewing some R stuff and some R Studio stuff, and hopefully build off of the last webinar that Rob gave. And then from there, the sort of meat of the presentation is to introduce 3 packages. One of them is sort of a very common data manipulation package used in R that works really well with Tidy HYDAT, which is a package that accesses Environment and Climate Change Canada's HYDAT database, as well as some real-time data, and then WeatherCan, which accesses meteorological data. I'm going to try and show an example of using them together, just in a very broad sense of just trying to show you some capabilities of using R. And then I'll talk a little bit about development and how you might be able to contribute to the Tidy HYDAT and WeatherCan projects. And then I also want to just spend a little bit of time, if we have time at the end, on where and then how to get help in R. I'm assuming there's a lot of beginners on the call, and I think that there's going to be some value in sort of discussing how we can ask questions. And then as well, there'll just be time for questions. But like Rob said, I mean, just please go ahead and go in the chat, and then I think Rob will slow me down if something's unclear or like that. So my name is Sam Albers. I'm a data scientist with the BC government. My sort of original background is an environmental scientist, working very much in the water space. And so I've spent most of my time learning to use R in that context. And that sort of accounts for a lot of the package development that I've done. I'm a maintainer of the Tidy HYDAT package, and then another package called RSOI, which is just looking at Southern Oscillation Indices, so things like El Nino and stuff like that, just bringing those into R. And then as well, I've contributed to other packages that includes WeatherCan, and then I'll talk a little bit about task views, but I'm a co-maintainer on the hydrology task view, which is a sort of a curated list at the Central R repository for packages related to hydrology and water movement. And I can be reached at those links below. So this is obviously a short 2-hour webinar, and so we don't really expect someone to come away with sort of being fully proficient in R after this. So this is very much a demonstration, and there's some links at the end where I'll sort of point you to that you can actually get a deeper understanding of some of this stuff. But what I'm hoping to do is describe the visual elements of our studio, and that's where we'll go next, so I won't worry about defining it. And then within that, I want to just get some basic R stuff out of the way, define and then assigning data to a variable, how you'd manage your workspaces and your projects, how you even call a function. And then from there, we were gonna sort of hopefully get some understanding of the 6 main dplyr verbs. So dplyr split into verbs that are functions that are sort of mapped to an English word that sort of hopefully makes sense in terms of the task that you want to accomplish. And then an overview of tidyhidat and weathercan functions. And hopefully you'll be able to come away with this with some idea of how you might use these projects, and then committing them to memory is a separate step. And then I'll show you a usage case of that, and then again we'll talk about how to ask for help. So just as a bit of a preamble for R, sort of a common analysis problem is how do we get data from these central agencies like Environment Canada? How do we get it, and what's the sort of most efficient way that we can build that into our workflow? And so some people would probably recognize this. This is the ECC Data Explorer, where you can pull hydrometric data from anywhere in Canada, and you can export that selection, and you can do some clicks to sort of get a bunch of CSV files, and then it downloads the data to your computer, and you get that here. And there's nothing wrong with this tool, but what happens if you run into the scenario where you sort of do a whole analysis based off that, and then somebody comes back to you and they're like, hey, we'd like to add 5 stations. Can you run it again? And if you've kind of gone through a workflow that's point and click and isn't sort of a scripted workflow, then you're basically going to have to repeat that entire process again. And so the sort of solution to this is to make it reproducible. And what does that mean? Well, that's sort of a scripted approach to data analysis, where you're writing code to accomplish a series of common steps, and you can automate that. And some questions that are worth asking when you're thinking about your analysis is, are your methods reproducible? And then you have a workflow, you have a question that you're looking to answer with this water or meteorological data, and what's your sort of analysis recipe? And can that be scripted? Can that be written down? Are those series of steps codified? And then if they are, how do you share that? And that's where something like R comes in really handy, where you have these series of steps that you've gone through, they work, you're confident in their ability, and then you can share that with your colleagues or clients or whoever might be interested in using it. And so in this presentation, we're going to focus on R. R is a language that was developed in the mid to late 90s. It's open source. It's very common. It's very popular, and it's very robust. That's not to say that there aren't other sort of computer languages out there that can accomplish the same tasks. So the sort of general approach here is to advocate for a programmatic approach, a programmatic code-based approach to analysis. Okay, so R, free open source, it's really got a large focus on statistical learning techniques and statistical methods. And this is because it was originally developed by statisticians. And so there's an obvious benefit there. A lot of basic statistical methods are built right in. R also has publication quality graphics, and we'll touch on that at some point, but it is an absolute beast of a graphics creator. It really has very advanced capabilities. What's sort of interesting in R is that a lot of the innovation occurs in contributed packages like dplyr or tidy hideout or weathercan. So the reason for this is that R is really concerned with that. If you have code that ran in 2005, the sort of most core elements of R would expect that that code should run just as well in 2019. And so that sort of conservative nature results in a lot of innovation occurring in these contributed packages. And you can kind of think of packages as sort of like an app on your phone. So if R is your phone, then the apps are the packages, and those are sort of providing additional functionality outside the base R. And so but it's definitely not intimidating, I promise. It's a pretty accessible language. So here's sort of our first little bit of code, and these are just sort of 4 numbers of hockey players, and we're assigning it to a variable by all-time great. So let's unpack that a little bit. That arrow sign, that's the assignment operator. And typically the way this works is on the left side, you have your name of your variable, which we call an object. So our object here is all-time greats. And then on the right hand, we have a function which is doing something on the inside of brackets. And in this case, C is just combining 99, 66, 4, 9 into this variable, and we're calling it all-time greats. And we'll cover this, but this is really sort of at its basic. You do something on the right-hand side, and then you assign it to something with a name on the left-hand side. So the thing about R is that you open it up, and it's really just sort of a little clicking cursor, and really doesn't provide too much advanced functionality. And so over the years, people have developed sort of some scaffolding to help you work in R. And the most popular and the most successful by a long shot is a program called RStudio, which is maintained by a company of the same name. And so we're going to dive into this, but it provides a place to run and write our code, and it's a way to organize projects. It's referred to in IDE. And sort of Ron Swanson will tell you, it still won't help you with wanting to throw away your computer. Certainly working with any program can be frustrating at times, but I think RStudio does ease some of that. So let's pop out of here and let's just have a little look at RStudio. So right here is the program RStudio. It runs on Mac, Linux, Windows. It's a sort of a clean interface. And we'll just kind of take a little survey. Right here, in this is just R. And so this is what I'm referring to. This is sort of just a little clicking cursor. And it's like, okay, I've got this program, like, what do I do now? And RStudio provides this kind of additional functionality. So the first thing you might do if you're interested in starting up a project in R is that you want to create a project, and RStudio provides a means to do this. So if you click and you go new project, and that's going to open up a little window for you where, say, I want to do a new directory and I want to set up a new project, and my directory name is going to be CWRA presentation. And that'll open it up into a new project. And what this does is, in this folder, CWR presentation, it creates this little .rproj file. And so anytime you want to kind of go work on some code or an analysis relating to this specific task, you can kind of just start by double clicking the R project file, and it'll open up RStudio. So the next thing you want to do is you probably want to write some actual code. So I'm going to just open up an R script. And here's like a distinction that is worth spending a little time on. In here, you can write code, and R itself is also just a very fancy calculator. So I could do 2 + 2 = 4, and I can do the mean of 1 to 10, 5.5. But what happens if you want to keep that code? And so we like to organize things into scripts, and RStudio provides a means to do this, where you can type code up here, And then there's some shortcuts, but you can just leave, you can highlight it, and then you can click this button up here, go run, and it sends it down to the terminal. And then say we want to save that code. You can go save as, and I can say, you know, calc mean, and then I have a .r file. And so then I've saved that code for later, and that's the sort of, you know, one of the units for sharing. So this is where we do scripts, and of course you can have multiple scripts open. It's sort of like a browser. You can have all sorts of tabs open here. This is R itself. It also provides this sort of stuff like you can navigate. So, you know, I save this calc mean here, it appears here. So this is something like the Windows Explorer where you can rename files. And then stuff may come up where you can view plots. You can see which packages you have installed. Your help comes in here, and we'll cover that in a little bit. So this is sort of a nice little handy way to help you interface with a bunch of functionality with R. And then last thing is that up on the top right, this provides some information about your workspace and your environment. So when you're working with R, the nice thing is that everything is saved into memory. So say you're working with some data, you actually work on a copy of that data. And this is where R shows you, or RStudio shows you the types of things that you have in your environment. So we just kind of covered assigning variables. So if I have a mean of 1 to 10 and I want to call that, you know, mean 1, this is a terrible name, but 1 to 10, something like this, and then I go ahead and I run that line again, and it appears here. And so what this is happening is that's being stored, and this is providing some information on what that is. So we'll come back to RStudio, but this is just sort of a general overview. And maybe I'll pause there if anyone wants to ask any questions.
Yeah, Sam, I don't see any questions with the exception of one about the WeatherCAN package, but maybe we'll bring that one up later in the webinar once you've introduced the packages. I will take a second to say that if you are watching this webinar and you haven't seen the first one, this is the second in the series. The first one was just a general introduction to R. So if you, at the end of this webinar, you find that the tidyhide and WeatherCAN packages are quite useful, but you are still a little bit rusty on some of the basics in R, I'll link the link to the archives for the CWA webinars, and you can find the previous webinar there, which is an introduction to R, like I said, and that will hopefully fill in some gaps that maybe don't get covered in as much detail on this one.
Yeah, definitely. Great. So, okay. So now we're going to pivot to sort of some of the utility of the code. And when you're doing data analysis, particularly, really in any space, often you're doing sort of repetitive yet interactive tasks. So, you know, you try and automate as much as you can, but at the end of the day, you might be iterating, going through something where you're typing code and you're trying to kind of hone in on a specific element of your data, and so you're repeating approximately the same thing, but just changing maybe, you know, the drainage size or the discharge or something like this, where you're really going through. And so, you know, that process happens over and over, but you're doing it, you're interactive, you're working with it. And sort of one of the things is that typically a hydrologist or water professional aren't computer scientists, and I'm certainly not a computer scientist. And so, you know, some of the more obtuse elements of computer programming really aren't relevant, or folks may not necessarily care about those aspects. And so all that is to say that it's helpful to abstract away unneeded complexity. So, you know, when I don't need to be getting totally into the weeds of computer programming, I just need to accomplish this particular task, but I want it to be reproducible and I want it to be shareable. And so that is sort of leads to an idea where you have a clean and easy to remember syntax, and that kind of reduces your cognitive load when doing analysis, and hopefully frees up part of your brain to actually focus on the problem that you're trying to answer, rather than trying to remember the R code. And so this is where dplyr enters. And this is one of these add-on packages that I mentioned. And dplyr is a consistent set of verbs that help you solve the most common data manipulation challenges. And really what that says is that typically there's only a few things that you really want to do when you're wrangling and manipulating data. And dplyr tries to kind of cover those in some really easy to remember syntax. And it's nice because it's sort of independent of the data source. And so, it works with all manner of data, bit advanced, but it'll work with databases, and it'll work with flat files, and it'll work on clusters, and it'll work on sort of most things that you can throw at. And it's the idea is it's designed for a data science approach. So it's certainly in line with this reproducible ethos that I'm sort of trying to talk about here. So just to go a little bit further into this, people talk about dplyr verbs, and the reason people talk about dplyr verbs is these are just functions, just like the mean function that we demonstrated, but they have names that are try to be mapped directly to the action that's being taken when that function is called. And so there's just a little line here of how you install the dplyr package. There's a standard way of installing packages that are predominantly at one source in R, and so you can just install it like that. And then there's sort of five variables here, and then one additional sort of special symbol that we can learn. So I'll just go through them. So the first one is this percent greater than and percent symbol, where we're using these to chain operations. And the easiest way to think about this is then. And so we call this thing the pipe. For anyone who might have kind of spent any time in a Unix background, it's a similar approach where you take the value of the first function, and then you chuck it into the next function, and you chain these series of functions together. And so what this really does is that you end up having steps. It organizes your analysis into steps that are sort of discrete and reasonably easy to follow. So we're going to see that symbol, and I'll try and review it a couple times as we go through, but we're going to see that symbol. That's probably the least intuitive one. The other ones are, like I said, trying to map the value to the name. So we've got something like select, and this speaks to a common thing where you're looking at a data file, and you really just want to select a certain number of columns, right? Like everyone's had this where you get some sort of spreadsheet where it's got 1 million columns, and you really only want 2 or 3. So select, it's very common aspect. So you just pick the variables that we want. Similarly, filter selects the rows that you want. So again, people might want to just select by a certain level of a variable, and so that just picks those, and we really get down to our the data that we're interested in. Summarize provides a way to take the means of variables, so we can really kind of group by certain variables, and then take the means or the max or any kind of summary statistic, and we can condense that variable or that parameter down into a single summary. And then arrange is just like a sorting mechanism where we can order the rows by a certain variable. And then lastly, mutate, which is one that will add variables to your data frame. So this is very common activity where, say, you want to divide one variable by another, and then that creates another variable in your data frame. And so I'll try and demonstrate the usage of these. But a really good tutorial is from the Software Carpentry organization, which is a really great organization that provides lessons and provides workshops for people that are interested in learning, both to be instructors and to be students. And so this link just provides a really nice tutorial on using dplyr that folks may want to check out. So let's actually do some more coding now. So dplyr. So we're back in our studio here, and we've got our sort of calculate mean script. So let's start a whole new script. So the first thing that you have to do is that you need to load dplyr. So as I mentioned, these are add-on packages, and when you install them, you have to actually tell R, okay, I want to use them. And so I'll run that, and then that makes it so that all the dplyr variables are accessible. And so dplyr comes with like an internal little variable called Star Wars. So this is some internal data. So this is, for exactly this type of purpose when you're looking to demonstrate the usage. Well, obviously our data will be really different, but this is just kind of a fun little data frame, which is Star Wars. So say we're interested for some reason in Star Wars, and we have this, we have an interest in say the, which people have the height of 172. So just to show down here, I typed in Star Wars, we got a print of the sort of first 10 rows of this data frame here called a tibble, which is sort of just a type of data frame. And this tells us that we have 87 rows by 13 columns. And here's the first 10 row. And so it's giving us some information about the data here. But say we're interested in individuals in the Star Wars universe that have a height of 172. So this is a filtering problem, right? Like we need to select the rows for where height equals 172. And really what it ends up being is it's a logical condition. So you look at this code that I've written, and what it should say is take the Star Wars data frame, then filter it when height is equal to 172, okay? So it looks like I've got, it's just Luke Skywalker. So that's like, a pretty narrow definition. Let's say we want to filter for rows rather than just explicitly equal. We want to go for height was bigger than 170, say. So we run that again, and we're going to end up having, a few more hits on this. It's all the variables, and what it is it's all the rows where the height is greater than 170. So it's just a logical statement. So now we've got like 54. So we've got some, some data to work with. So if we take that again, and now we're maybe interested in another task where we're not really interested in sort of all these variables here, especially some of the other ones that were just not part of our analysis. So we're going to do a select, and then we'd say we want the name, and we want the height, and we want species. And that gives us a really simple data frame. Now, one thing I want to pause on here is to sort of hammer home this point of an easy to remember, easy to read syntax. In a lot of cases in programming languages, you're going to see all sorts of strange variables that are surrounded by some manner of square curly brackets with some type of obtuse symbol that sometimes gets a little confusing. Does this one surrounded by a curly bracket, a square bracket, a dash, a % sign, or whatever? Whereas dplyr provides this kind of nice syntax, right, like this, where you just provide the bare names of each variable. And I think that ends up making it a nice syntax. So, okay, we've got that sort of simple data frame. And then maybe we want to do some summary statistics over it. So a function that I haven't really talked about is one where we might want to add some grouping to the data. Excuse me. So we've got something like species here, right? So we want to group by species, and our goal here is we want to actually summarize, and we want to take the mean height per species. And so I'll just write this code and then I'll explain it. But basically we're using the summarize function to get the mean of the height, and then we're assigning it to a new variable called mean height. So again, we're sort of chaining all these operations together to provide sort of a fairly clear analysis where we sort of from the Star Wars data frame, take those with a height of greater than 170. And then for ourselves, we want to select a few different variables. We want to group it by species, and then we want to summarize using the mean of height. And then what this ends up happening is you get all these sort of two Star Wars names of species, and then we get the mean height of that. So it's fairly sort of simple, but you can imagine this in a sort of water practitioner sense where you're frequently wanting to calculate the mean or some other summary statistic by group. And then just to sort of go a little bit more, we have to say we want to arrange, and we want to arrange by the mean height. So we want to rank these by the mean height. And just if probably something that was useful there is that RStudio provides some useful things for you. So it provides auto completion. So I've already created this variable up here by mean height, and then RStudio actually kind of says, okay, do you want to use those? And you can actually see it has the one that we created before, which is obviously not what we're interested in, but then we mean height, and then you can kind of use your arrow keys to go down it and then enter it. And it kind of can save you some typing, and you can actually save quite a bit of time doing that. And so we've ranked it by smallest to largest, doing that approach. And then lastly, you can notice that there's a little NA in here. And so everyone has probably dealt with these types of things where, excuse me, where we've got, some grouping, which is, an undefined value. It's some miscoded variable in the raw data, or it's something. Everyone's dealt with missing data. And so, we've got this far, and I'm like, well, I don't really want to have that NA in there. And so again, this is a row operation. So I want to use a filter, and then so this is where we get into a little bit of a slightly more complicated syntax, where I have a function called isNA, and I want to use it on species. So I'm saying, give me the rows where I have isNA species. And so if we just run that, what it does is it ends up giving you that one row that was an NA. But I'm not really interested in that. I want the opposite of that. And so what you can use, and which is a common thing, is you use a exclamation point, which just provides the inverse of that. And so then I've managed to sort of remove that. Okay, I'll pause there because that was maybe a lot. Any questions there?
Yeah, this is a good time to run this interactively and ask some questions. I don't see any here, but maybe we'll take 15 seconds just in case there are any questions about dplyr and the example here.
And again, the point here, right, is that like, okay, I've done this analysis, and it's like, okay, maybe I actually wanted, height greater than 200, and you can run that really easily and get a whole, similar sort of output. But when you do this, it's reproducible, and then B, the syntax should be reasonably. I find it sticks in memory pretty easily. And this is not. I should have said this before. This is not a replacement for the sort of more traditional BASER approaches. This is just another approach, and either any of them are equally valid. And if you can get your job done in any which way that you can, that's the goal. And this is just trying to present an alternative approach.
So Sam, there's a quick question here. What about using na.omit as a function instead of the exclamation mark is.na? Would that work basically the same way?
I can't remember NA omit. I always use, okay, so now I'm going to do something where I've used question mark NA omit. Okay, and so that I hit enter at the command line, and it brings up over here some information on this. And if I remember correctly, NA omit is a little bit more of a like broad strokes, where it removes all NAs from a data frame. I never use NA omit. Rob, do you use NA omit?
I don't think I have. I'm guilty of using the exclamation mark and which is NA function.
Yeah, right.
Sorry, there is another question here about relating this to excluding outliers. Are there maybe some useful functions to look at outliers with the dplyr package?
Well, certainly there are. I mean, like I could do something like this. So let's say just take this chunk here, right? And say I was interested in, I mean, obviously you have to define your outlier, which is a whole conversation unto itself. But say we were just interested in the max, right? So I went max height. So I've again, for some reason I'm looking to filter by 200. I want to select these variables and I want to find the max by species. So, that could be one criteria for an outlier. Just to go back to the NA omit, this raises a point in that in R, there is like always multiple ways of doing things, and sometimes they're completely equivalent. And that is just sort of a product of development and people sort of, somebody had an idea for something in 2005 and it never got rid of, and then somebody reinvented it in 2015 or something like this. So yeah, I'm not trying to be too prescriptive about it, but isNA is an approach that I found to be useful. Yeah. Anything else?
Yeah, and maybe one more question here before we move on. It says, where can we find all the commands? Is there a dictionary of all the commands? And maybe in the same note, you might have this later in the webinar, but sort of a useful set of instructions or cheat sheets for dplyr.
Yeah, so I got some links in the end. So dplyr definitely has some cheat sheets, and I mean so I've got some links at the end of the webinar, but there's definitely cheat sheets, and if you just Google dplyr cheat sheet, it would definitely be the first thing that comes up.
And Sam, correct me if I'm wrong, but I think there is a way to bring up all the functions within a package as well. Is that right?
Yeah, so you can go, oops, and I do that later. I'm just
okay.
code, but no, this is great. And so you can go help, package, and then let's just do dplyr like this, and that'll, oops, I have to actually run that code. So that'll bring it up down here. The only issue is that this is like an unadulterated, list of functions. So, like there's a lot in here, right? And they've got, some of them are helpful, but it's like, find one that's particularly obtuse. This is not necessarily the place where, so dplyr is very well documented, really great documentation. This is not necessarily the place, but rather you kind of click on here, and then you've got these things called vignettes that are called, and we have some for weathercan and dplyr, but if you kind of click on here, but I wouldn't worry about how I got here. If you just click dplyr help or dplyr, search dplyr vignette, it'll all come up on the web, and there's really great documentation from the authors of this package. It's really well documented, I promise.
Great. I think that's good for now. We can probably carry on.
Cool. Okay. So, so this brings probably to the reason why you're actually here, is to sort of understand how to use Environment Canada data sources in R. And this was sort of a problem that I ran into using Water Survey of Canada data. And so I decided to write a package for this. And so the objective of Tidy Hideout is to provide a standard method of accessing ECCC hydrometric data sources, both historical and real time, and then use like sort of a consistent and easy use interface. So drawing on the principles of dplyr, hopefully, to sort of provide easy to remember functions. And then the other thing, if anyone's ever worked directly with the HIDAT database, it has some historical reasons for this, but it's in a little bit of an unwieldy format. So behind the scenes, Tidy Hideout turns things into a bit more of a tidy data frame, but just a more usable approach. So like I said, this pulls from the Water Survey of Canada network. So this is just a little map of Canada, looking at the points, and these are all the stations in the database, both active and discontinued. So that's 7,000, almost 8,000 stations in the database. The database itself is 1.1 gigabytes, and it's a SQLite database, which is really great that Environment Canada publishes the data in that format. SQLite is like a very usable, portable, accessible, and self-contained format that we're able to leverage in R. And so that's all the data is contained in there. And so that's actually published quarterly, so that it gets updated as data gets verified. And that is the primary data source for Tidy High Det. Although we can get real-time data. WeatherCan, which is another package that I'm involved in, really tries to accomplish the same task, but for meteorological data. And so this is, WeatherCan provides a standard method, again, of accessing ECC climate data. And it's, again, trying to be a fairly consistent interface. And again, trying to employ tidy data principles within R. And both of these packages are sort of slightly different, and that reflects the different way that Environment Canada disseminates both these data sources. WeatherCan relies almost exclusively on a web approach, whereas Tidy High Det, what happens is that you download the High Det database and then you work directly off that, and that's just a reflection of what's offered. And so WeatherCan does the meteorological network of stations. And so here's a map of the stations. And I mean, it really is actually amazing to sort of look, and you know, you've got 79 or almost 8,000 stations there as well. And I think most of these are active. Instead of being available, it's locally, it's available online. So you will need an internet connection for this. So let's look a little bit closer at these. Does anyone have? Well, no. Let me kind of work through this a little bit, and then we'll pause for questions. So we're going to look a little bit closer, and we're going to look at actually, you know, how to code and work with this data. So this is working a little closer with Tidy High Det and WeatherCan. So like I mentioned, first we'll go with Tidy High Det. The first thing that you want to do is you want to run a function called download High Det. And what this does is it, strangely enough, downloads High Det. And there's some functionality built into Tidy High Det that it'll let you know when your High Det is out of date, and you're going to have to re-download that from time to time. And that's going to take you, depending on your internet connection, anywhere between 5 and 15 minutes. So it's kind of like, you know, if you're getting started on this, sort of expect to have a period of inactivity where that's just downloading. And that'll store that in a standard location in your computer. You're never really going to have to deal with accessing it directly. All that kind of happens under the hood, but you do have to do the manual step of downloading it. And then when you come in here, you're going to have to do a similar approach that we were just talking about, where you're going to have to use some functions to access this data. And so let me just unpack this flows data here. So this one that I've got right here. So one thing that I'll try and reiterate, that the whole game here, the whole important part of both WeatherCan and Tidy High Det is that you have to supply it. The most important thing that you supply it is the stations that you want. And we have different formats for the WeatherCan and Tidy High Det station numbers. And, you know, some of them are, you know, the Water Survey of Canada station names, I'm sure, or station numbers. Everyone or many people, I'm sure, are familiar with those. And those are what sort of drive the data we extract from the database. But if we look at this in an R sense, what we have, if we're moving from left to right, the first thing that you can see is we've got this flows data. So this again is the object. So this is what's being created by the right-hand side of this. And then we've got this assignment operator again saying everything on the right-hand side, assign it to this variable flows data. So that's kind of, this part here is just the R part. And then this is what Tidy High Det brings to it. So it's HY, which is sort of every function that accesses the High Det database is prefixed by an HY underscore, and that has some benefits later on. And then it's what type of data are you looking to access? So in this case, we're accessing daily flows. So this is the function name, HY daily flows. That's kind of the top level citizen in this operation here. But we don't just want sort of all the data at once. We want a subset by some variable. And the most common one is this station number. And so we call this an argument. So it's an argument to the function. And then the value to the argument is these 4 station numbers, which are provided right here. And I've supplied these right now for the example, but your trick, your sort of, challenge is to sort of hone down in a way with your data to figure out what stations you actually want to look at, and then you can access the full functionality of R. But and I'll show you some approaches to get down to that. And of course, just a quick review on these. These are there's information embedded in these codes for anyone who doesn't know. So this is the sort of top level drainage basin. So 8, correct me if I'm wrong, I just think that's the Pacific. And then this is a sub drainage, M is a sub drainage, and then a F is a sub drainage. And so you can sort of, these are nested in within here. And, I probably should have shown some, but, 08M H005 is in the same sub drainage, but a different basin drainage. Hopefully that's clear. That was a bit rambly. So what else is a bit? Sorry, go ahead, Rob.
I might just jump in for 1 second to say that if you are running this live, this might be a good time to call the tidyHiDAT library and download the HiDAT database and maybe try to be able to run it in real time for the certain part of this webinar. And there is a question here if you want to talk about whether you need to find the path of the HiDAT database or if that's taken care of on its own with the download HiDAT function.
Yeah, so that's taken care of on its own. It's platform independent too, so it's like it just stores it. So on Windows, it stores it in the app data folder in your user, and then that's always accessible. That's the default. I mean, you do have the ability to change the path, but there's I can't really see any reason why you'd ever want to do that. And similarly, it stores it in a default location on Macs and on a Linux system. So you don't have to worry about it. The only thing you have to worry about is keeping it up to date.
Perfect. And you'll probably get to this later, but are there cheat sheets also available for the tidyHiDAT and WeatherCAN packages?
No, there's not, and that would be like a great. And I'll cover this at some ways of ways that folks can contribute. And I should have added that. That would be if anyone ever wants to do that, that would be great. And I can say for both those packages, we would include those, right in the sort of central repository.
And I have my own quick question before you move on, which is who came up with the WeatherCAN package logo?
That was Steffi. So, I completely, and thanks for that prompt. So I am a sort of the B author on WeatherCAN. The main author is Steffi Lizert, and she is a talented R programmer, and she's the sort of maintainer of it, and actually very nicely pushed out a fresh, just as of today, version of WeatherCAN with a bunch of bug fixes and some really nice new features. But yeah, that'd be Steffi.
Nice work.
Great. Yeah, and those these little hex stickers are you see these often in the R world, and they're sort of just like a fun, silly way to make your package recognizable and get some stickers printed and put them on your computer, and it's just something that's kind of fun. Okay, so what else is available? So Environment Canada does just a great job of providing some other tables. So I just showed probably the most common one that folks would be interested in is the daily flows, but there's a whole bunch of other things, and I've got this code right here, C help package tidyHiDAT, and that'll bring up that list of other things. But we can also access real-time data, which does require a web connection, but that can also be really, really useful. And actually, I'll show an instance of that later. There's instantaneous peaks. There's daily and monthly, yearly temporal summaries. You can get different types of parameters: discharge level, sediment, particle size, data ranges, and then one of the most important is the station metadata, which is sort of the top level one of the ways that you might actually hone in on the stations that you're interested in. And then as well, there's sort of some basic diagnostic things. If you just feed a tidyhi.object, so anything that you've created with tidyhi.code to the standard rplot function, it gives you these sort of basic plots. I certainly wouldn't advocate for anyone publishing with these, but they do give you a quick look at what you might be seeing. And then as well, it provides some functions where you might search for data. And again, this gets at these kind of this stuff that where you're, how do you hone in on some stations? And so search station name, and then we've got Fraser, and this gives you all the stations on the Fraser River as well as one on the Notley near Fort Fraser. Okay, so now we'll just we're going to do some more actual coding, and I'm going to try and demonstrate some tidyhi.dat stuff. So we'll open up a new window here, and the first thing that I want to do is I want to show, okay, so again, we have to load tidyhi.dat. So we load that up. And then again, we're going to use functions from dplyr. So we're going to load dplyr as well. So often at the top of an R script, you see this kind of thing where you see all these types of things. And in the interest of kind of keeping this organized, we might want to put some notation up here. One way to do this, RStudio provides just a shortcut. It's Control-Shift-R, and this kind of allows you to label a section. So I'm just going to call these packages, enter, and that kind of gives you sort of that type of organizational structure to your projects. And this becomes like really important. I mean, this is kind of a separate topic, but keeping all this organized becomes a challenge, and there's lots of literature online, and we can maybe do another webinar on how to keep this stuff organized at some point. But say I want to do something where I'm going to call this analysis. It's pretty basic analysis, but I'll just organize this again. So I've loaded tidyhi.dat, I've loaded dplyr, and then I want to access this hy stations. So this is hi.dat stations, and if I run this, what this is pulling out here down here is every single station in the hi.dat database, just metadata. And if we just kind of go from left to right, you can see there's those 7,000 or almost 8,000 excuse me, stations. We've got station number, station name, which province it's in, or if there's some outside of Canada as well, regional office, HIDE status, excuse me, sediment status, lat longs, drainage area, all these types of useful information. So what we're going to do here is first we're going to assign this. So let's just call our thing that we're creating here hi.dat stations. And so we've created a whole data frame here of hi.dat stations. And this is the first time that we've actually assigned a data frame. So I'll just take a moment to talk about what RStudio can do. If you see it's appeared up over here in our environment. So this means that we've saved a copy called hi.dat stations in memory, and we can see it in our R session. So you click on this little blue arrow, and it can provide you some information on the columns that are in the data set. But even sort of more useful, I think, is that you can actually just click on the thing itself, and it provides sort of an Excel-like interface to actually look at this data, which is sometimes handy. You want to look at stuff that you're interested in. It provides functionality where you can filter or you can do stuff, and it's a way to quickly explore so that you can go back and you can kind of codify what you're actually seeing. So say I'm interested in some sort of task where I want to look at a certain size of drainage areas across Canada. So I know I've and again, RStudio provides that sort of, I typed hi.dat, and then RStudio provides me sort of some suggestions of what I might use. So the first one I want is the one the first one given is the one I actually want. I type enter, and then I'm there to go. And now I want to do this pipe. So remember, this is saying hi.dat stations, then do something. And in this case, what I want to do is I want to select for some drainage areas. And so drainage area gross is what I want. And say I want to go for really small drainages. Okay, so I'm just going to go for ones that are smaller than a kilometer. So I've gone from 79,000 or 7842 down to 79. So there's 79, 79, or yeah, there's 79 stations in HIDAT that are less than 1 kilometer in size. Now, the next thing I might want to do is, like, I can see right away, this is this number here, I can see right away that, like, oh yeah, there's going to be a pile of them that are discontinued. And say for whatever reason, I'm interested in only the active ones. So, okay, I want to take hide status. And again, RStudio provides that useful thing. And I only want active stations, okay? So now we're down to like 3 stations. So there's 3 stations in the country that are less than 1 kilometer that are currently active. Now I'm at a point where I'm like, okay, I've got, for some reason, that's the question I'm interested in. Now I just want to get those 3 station numbers here so that I can supply them to another function. And so what I want to do is I use a new function that I haven't really introduced, but what it does is it just extracts the single station number. So let's just look at what that looks like, and maybe it'll be clear. So run that, and it's just got these 3 numbers, okay? Now, as it stands, those are actually what I can feed directly into a function when I actually want data. So if I go small stations, or small drainages, sorry, let's do that. Small drainages, and I'm going to assign that. So after all these sort of manipulations, I'm left with a variable. And if I go down here and just type it in the R console, small drainages, those are those 3 stations. Okay, so then maybe what I'm interested in for some reason is I want the annual instant peaks. And again, here's why something like having the prefix in front of your function is really handy. Is I type HY, RStudio provides every single function that accesses HIDAT in here. And so as it happens, instant peaks is what I'm interested in. And because, so I want to go station number, which again is my argument. And then instead of putting in something like, you know, that's the Fraser River, right? Instead of manually putting it in here, what I can actually do is I can just give it the variable we just created, which is small drainages, and then run that. And so now I've got the annual instant peaks for all drainages less than 1 kilometer squared that are currently active in a pretty short amount of code. So that's something where, and then maybe, you know, we're actually only interested in some sort of subset of that as well. So further honing in down on what we're interested in. Maybe what we're interested in is some sort of start and end years. Well, all these functions in HIDAT also provide a temporal way to sort of get at that. So you go start year, and I'm interested in 1970, and my end year, for some reason, say I'm interested in 2010. Oops. So right now, like, we've really trimmed down. We've got a fairly narrow sort of set of stations over a fairly narrow time range, and we're really at the point where we're able to get some interesting results. Let's just look at some other functions. So I mean, this, you know, now we have this data in R. Let's just pause. So R has an amazing array of statistical techniques, plotting capabilities. But what we've done, and you know, at some point I feel like you'll have an aha moment where you're like, oh, this is super useful, because this gets it into R in a reproducible way, right? We've got this code right here that we can share with somebody, assuming they've downloaded the HIDAT database, and it can point them exactly to the analysis that you want to do, and then you can subsequently do all the amazing functionality that's offered by R. And I just want to demonstrate a couple other data types that are available in the HIDAT database that we leverage. So some annual statistics. So these are sort of more, you know, your sort of MAD values, your mean, your mins, all these types of things. there's levels as well, obviously, because you've got your flows, but then there's also the actual level data all available as well. And then lastly, there's kind of a useful function that you take. Oh, so let me pause for a second. I just did something which maybe was not terribly good, but I'll explain it why I did it. As I omitted this station number equals up here. This I omitted this, and what I've done here is I know it's the first argument in the function, and so I can omit that call to it, and then I just have that variable, and it automatically gets assigned to this argument there. Probably not the best thing to do right now, but just kind of old habits die hard. So this HY daily grabs the levels, the flows, the sediment values if they're there, and the particle size, and just kind of collates them. So what we've done here is returned all this data in this place. I'll pause here because there is some information. Every time you query the HIDAT database, I've added this little bit where it sort of gives you some information on what you've grabbed. First of all, it gives you the version of HIDAT that was released. So it was released in mid-July. How many observations you want. There's a whole bunch of measurement flags in there, to do with ice or I mean, I'm sure everyone's familiar with all that kind of stuff. What parameters you actually grabbed. So here I've grabbed flow and level. The date range that I've actually grabbed. So for those stations that we've looked at, it actually covers the period of 89 to 2018. And then stations returned, so 3, right? We started with 3, but sometimes that data is not present. So we might grab a station and then we might look for it over a time period when it actually wasn't running. And so we may have an example where a station was requested but not returned. And so that gives us some information about what maybe it's not returned. And these are sort of useful for exploring your data at a really high level.
We've generated a good number of questions here, so we might take a quick pause.
Right.
There's a question.
And we got an hour left, right?
That's right. Yeah, just under an hour left until 2 o'clock.
Perfect.
So there's a quick first question here is, can you map the entire all the stations in Canada? Someone else pointed out that there's lat-long coordinates there with every station. Are there any other utilities in the Tidy HIDAT package for mapping?
So no. So I'm like a firm believer, like the whole point of Tidy HIDAT is does one thing and it does it well. But there are definitely, so the map we saw before of all the stations in HIDAT, that certainly was done in R. And that was actually, so my presentation itself is done in R, and all the code to create all the figures is in there. And so I didn't want to go into the spatial stuff, and again, that could be a topic of another webinar, but the code to create all the maps, and I'm actually going to do a spatial analysis next or in a couple steps now. So the code is there, so you're certainly welcome to try it, and the link to that code will be the last slide in the but there are, R is its own GIS platform. It's pretty functional, like except for some pretty edge case stuff, R can fulfill all your GIS needs. And so, we're working with kind of things like HIDAT. It provides a really nice place because you can do spatial operations to narrow down the stations that you're interested in. And that's actually the example I'll do in a little bit.
And then piggybacking on that, someone pointed out that the coordinates for that long only show up with 1 decimal place. Correct me if I'm wrong, that's just the format for how Tibble displays the data. The full accuracy of the coordinates for latitude, longitude, and other variables are still within that database. Is that right?
Yeah, yeah, definitely. So that's just a printing thing here. But Tidy HIDAT just draws directly from HIDAT. So whatever, I've never actually looked at what precision the coordinates are, but it will pull whatever is published by Environment Canada. So
perfect.
Yeah.
Is Tidy HIDAT only available for certain versions of R?
Only it's a pretty it wouldn't go back to very early versions of R. It does have some dependencies, and I try and keep it up to date, but at the same time, so we would probably work with any R in the last sort of five years maybe. But as a general comment, there's kind of, I mean, when you work in an institution and you don't have the ability to install your own packages, that is a hassle. But generally speaking, you should be working with the most recent version of R and the most recent version of all the packages. There's exceptions to that, but really, as a rule, that should be the approach.
Perfect. And then maybe we'll take one more question here before we keep moving along, which is that the HY annual instant peak for small drainage areas are appended one after another. Is there a way to see the data for each station separately?
Yeah. So I mean, it works out that it's a little bit easier. I think your best approach there would be is to call it individually. There's a couple ways to do it, but when they're all appended together, it actually makes working with it in terms of like, if I want to do a mean by group, or if I want to do some sort of operation where I'm grouping it by the station number, it ends up being working with it to do. It works better when they're all appended. So it's kind of done by design. The way that you could do it, I mean, I'm kind of getting into territory where I'm kind of not going to explain this super well, but you have small drainages, right? You have this small drainages, it's called a vector. So you can subset a vector with square brackets. So I could do 1, 2, or 3, right? So if I copy that and say I'm interested in the third one, and then I do this, oops, I've returned only that one station because I've only asked for this one time, or one station. But this is kind of in this long, tidy format, and I will sort of advocate that I think at the end there's a lot of benefit to having them all in one place. I'd be curious to actually know why one would want them separately, but maybe not right now.
One last question, just because it's relevant to the version issue. Someone reported an error or a warning on installing packages at TidyHi that's not available for version R3.6. Any comment?
So are you sure you have TidyHiDat? We can talk offline, but like, did you actually? We sure it's typed exactly like that? Because if I did something like this, if I did TidyHiDat like that, and my computer's saying, oh, not available, right? So if there's a typo in there, that would be a very good reason for it. Definitely is available. I'll show you some ways that you can reach out and ask for help later at the end on that exact type of thing.
Okay, awesome. All right, yeah, carry on.
Cool. So, okay, on to WeatherCan. Now, WeatherCan has some subtle differences, but it's approximately the same approach as TidyHiDat, where you have a function that calls the data. You have a station argument, so you want a station that you're interested in. Where it differs is that Environment Canada bundles the types of days or the types of intervals that you might be interested in. And so here we're actually just interested in the interval day. We want daily data, and that actually changes the type of data that's returned. As you can imagine, hourly data and temperature data. I mean, hourly data for precipitation it doesn't exist as far as I know, and then daily data, you've got that sort of average daily precipitation type of thing. But it does have sort of a time range where start is 2019, January 1st to the end of the data that you're interested in. So this parameter right here is really helpful because all this data is coming across the web. So you really want to sort of, there's a lot of data, and if you want to make it manageable to download, you want to narrow in on the sort of minimum number of data points that you're interested in. This is just a a station in Victoria where I am, where I've downloaded sort of that month of data in daily intervals. And so you can see there's 31 rows, and then there's 37 variables. And we won't explore every type of variable that's present in the database or in the WeatherCan, but you can see from here all the types of things that are available, the temperature flags, mean temperature, all these types of things. WeatherCan provides some really good, as well as Environment Canada provides some really good descriptions of units and the type of data that you're actually getting. So what else is available in WeatherCan? Again, you can see this help package WeatherCan that'll give a list of the functions. What's really exciting right now about WeatherCan is actually providing normals, so climate normals for a selection of stations in the country. And that becomes really useful. That data becomes available in R. It's brand new to the WeatherCan package. I'm not actually going to demo it today, but that provides a means where you can kind of grab your data and then you can compare it to sort of Environment Canada calculated normals, which is just very, very useful. And then the types of measurements that we get there. And then the important thing is that it also provides the station metadata. So very similar to HIDAT, we've got a data frame that we can use to make some decisions on what types of stations we want. So let's bust out and we'll talk about WeatherCan a little bit now. So just go back to RStudio. I'll open up a new R script. And in this case, we want to, this is gonna be a very similar demo, but I wanna load up WeatherCan, and then I wanna load up dplyr again. And again, we wanna organize our script. So I'll just say packages, and then again, we'll do some analysis. So the neat thing about, let's see if just bear with me for a half sec. Okay, so say we're interested in some subset of stations. So in WeatherCan, that data frame is called stations, and it's included in here. And it's, looks reasonably familiar to the Tidy HIDAT one, where we've got stations, and then we've got some IDs, and we've got some names, and we've got lat longs, and we've got elevation, we've got time zone, and then you've got a range of what types of intervals and a range of the time that you're interested in. So this becomes really useful, and this is something worth exploring as you use WeatherCan. But what we're interested in, let's say for a second that we're interested in elevation, like really low elevation stations. So we're gonna go filter, and then we've got this column elev, which is a short for elevations. And say we wanna do everything that's less than or equal to 1. So this is gonna give us, sort of a big subset of stations. So if we started out with 26,000 rows, and we've actually bombed down to 84 rows here. So we're in like a much lower subset of values. And then, I'm actually just interested again in data that is only available current, right? So there's some data here in this end column where, data collection stopped in 2017. Maybe they were never collected over a monthly, there's no monthly summarization of that, or they ended here. So I'm really just interested in current data. So I'm gonna go end, and this is equals 2019. So again, I'm looking at rows that are where elevation is less than or equal to 1, where they end in 2019. So now I'm down to like a really manageable, I'm down to 14 stations. And let's say for this approach, I'm actually just interested in data that has an interval of a day. And we'll just do that as sort of a happy medium. Hourly data just takes quite a while to download. So down to 7 stations. So these are 7 sea level stations, end in 2019. And they have an interval of the day. And I'm interested in pulling out this column, the station ID column. So unlike the way that hydrometric stations are delivered, as far as I know, and please anyone pipe up if wrong, these don't have embedded information. They're just numbers. I could easily be wrong on that, but I don't, not to my knowledge. So, but what I do want is I want those station IDs. I want to pull those out and I want to feed those to the main downloading function. So I've done that here, where I've got those 7 stations. But I have to remember, I have to assign this to a variable so that I can call it back when I go to the downloading function. So I'm just going to call these sea level stations, and then I assign it like that. And so if I just type in to the console here, I got sea level stations, it's those ones. So I've honed in on those sort of 7 stations, and now I want to actually download the data. And the main sort of workhorse function is weather.dl, and I want station IDs, and I'm going sea level stations. So that was a little bit quick, but what I was able to do is just kind of leverage some of the autocomplete aspects of Environment Canada's, or I mean of RStudio. Now I want, so I'll just assign this again to a data frame, sea level data, and then I'm going to run it. And so what's happening now is this is going out, pinging Environment Canada servers, downloading all the data, tidying it up, and bringing it back into our session. And so that's going to take a little bit. So in the interest of not wasting any time, does anyone have a quick question while we wait for this to download?
There are a couple of questions jumping back to the tidyhidat package.
Yeah, that's fine.
Yeah, there's a question about changing the download destination for the HIDAT database manually, which I think can be done with the download HIDAT command as well, but maybe you want to comment on that?
Yeah, no, it can be done. Yeah, it can be done. The problem is that every single, let me just pop to here so I can, so I'm just kind of, here's like a documentation page for tidyhidat, and I've got links to that later. But if we go look at sort of some, so let's say HY daily flows, right? So this is some documentation for HY daily flows. We've got this variable here called HIDAT path, which defaults to the path that I set where we download it. So if you downloaded HIDAT to a different location, every time you called it, you would have to reset this path. So just creates a little more work. Assuming it's sort of some IT constraint, there's a way to do it, which is that. And then also download HIDAT itself, it says download HIDAT here. So it's saying like, here's where we would like you to download HIDAT, and that would have to be the same as what we have in the other one.
And just since you've now jumped to the page here, there's a question about, is there a manual for these packages? And it looks like maybe the page that you're on is probably the best resource, is that right?
Absolutely, and I'll cover that right near the end, but I should probably blitz through. This is taking a little longer, and of course I'm on my home internet, so I'm going to actually just leave this for a second, and everyone just can basically trust me that this will download, and the perils of a live demo. Hopefully this is actually a little bit worried that maybe something's gone wrong, but I promise it works.
So maybe one more quick question here, and then I'll let you jump back to this to see if it will work. The question that was posed earlier about basically how late the data can be updated which I think is applicable to tidyhidat, but it's being asked about WeatherCan specifically, because I think when you in general call the data, it goes up until like at the end of the previous year. So for example, if you call it now, it goes to the end of 2018. Is that right? And is there a way to get the latest climate data in the WeatherCan package?
So this will have the latest. So the WeatherCan data will have the latest climate data. This is taking much too long. So this will have the latest climate data. This is a dangerous approach. I'm just trying to reinstall WeatherCan. So WeatherCan will grab the most recent weather data available. Tidy HIDAT has a different process for validating, so data gets added to the HIDAT database, and that can be anywhere near, you can have, there's no standard there. So like the goal is to have the most recent up-to-date data, but it can be, as late as 2015, and that data is more, the HIDAT is more for historical work. We do have a function, which I'll show in a second, which is real-time data, where you can grab unapproved preliminary data from Environment Canada for the past 30 days for hydrometric data. Let's see if this, let's just try, we're gonna just, on the fly, I'm only gonna grab 2 of these stations just to see if that'll reduce my download time.
Great, and Sam, maybe while you're running this, there's a request to also just review what's happening on line 17 there.
Right, so this is the weather download function, which, typical live demo is giving me some grief right now. Not totally sure. Oh, I know why. Sorry, I just figured out why. Because in this, you have to also set the interval that you're interested in. So what I was trying to do, okay, let's just pause for a sec. This function right here is the workhorse function to actually download the climate data. The next element of it is the argument that accepts which stations you're actually interested in. And we did this kind of dummy example where we went to low elevation stations that ended in 2017 for interval day, so daily interval data. And then the last argument here, which I'd forgotten, which is the day. And so we only want daily data. So what it was trying to download is hourly data for quite a large data set. So if I just run this, it should work, but we're gonna bust back. Yeah, there we go. So so that downloaded. If we look at sea level data, that's daily data for those 2 stations that we subset here, and then this gives us a whole bunch of precipitation, temperature, all these kind of things. And that data then is available in R. So if we go back to this, that was the WeatherCan. So I'm going to try and give you a sense of maybe using them together. I'm going to give you a sense of how we might use spatial data to narrow down the stations that we're interested in and then provide some information. And this is a little bit more of just a demo approach here. Won't code this anymore, but what I will say is that the code for this is available at the link that I say at the end. So so I tried to kind of grab a relevant example. Hurricane Dorian obviously just ripped through a few parts of the world in September. Pretty awful thing. And it also had a brief stint where it spent some time over Nova Scotia. And so again, all this is made in R. This is just a picture of North America, and then that path is provided by NOAA, which is just the path of Dorian as it went over the Atlantic. So if we're interested in a point, they provide them as lines or points. If we're interested in the point where Dorian is over Canadian land, we can just do a simple sort of spatial intersection to look at which point actually falls over land. And you can see on that down in Nova Scotia and that bright purple dot, that's where NOAA was over Nova Scotia. Obviously it's not a line, but this is just a point that we're using to sort of narrow our focus. And so if we were say interested in what happened over some sort of radius around that point where Dorian went over Nova Scotia, this line or this plot right here just shows these 3 maritime provinces with a 70-kilometer radius around that central point. So we're looking at sort of 70 kilometers right around that circle. And then we're interested, okay, well, we can ask the question, well, what hydrometric stations are in that 70-kilometer radius? And that's sort of a proxy of, what stations were, really in the path of this in the path of Dorian and where we might have seen an effect. And so we can look, there turns out to be 6 stations in the path there, and they're all sort of reasonably spread out, but there's a bit of a concentration. But we can look at that data to see if we can detect the influence of Hurricane Dorian. And so the way that we do this is I've done some analysis to subset the number of to get those stations. So I get those station numbers. And again, that code is available to you, but the point that we need to learn is that we've got that data. We've got these 6 stations. And so I'll introduce a new function that essentially does the same thing, but it grabs the real-time data. So it's real-time underscore DD. And then if we feed it a station number, this will pull data from the web. And again, we're giving some information about when it was queried, the date range that we're getting. So we're in the date range of when Dorian went by, and it's October 25th to September 25th, so today. And what we see is that those are the 30 days that are currently provided by Environment Canada. And then you can see actually that the interval of this data is in 5-minute intervals. So this is pretty high resolution data. And I decided to subset by level. So this is just the level data that we're going to be looking at here. So what we can see is this is a plot of that data. So on the left-hand side, we've got level, and then over the bottom, we've got date. And then these panels are split up by station. And these are the 3 stations in Dorian's path. And then that dotted line is the NOAA. So from that, the shapefile that I grabbed from NOAA, they have a date of when Dorian was at that exact point. And so that's plotted on there. And obviously you can see like a fairly large spike in level in all these hydrometric stations, because obviously a lot of precipitation fell with NOAA. And so you could just, the point here is just to show that we're able to detect that real life event, and we're able to use that data. We're able to grab all that data directly in R, and we've stayed in R for the whole time. Similarly, there's the climate data. And so if we have take that same radius, there's, conveniently there happens to be 6 climate stations in that same area. And so again, we have this up here, we have the station ID. So we've gone through and found this subset of stations here, and they all have an ID, and we've found those. So a little bit beyond this webinar, but we feed those into this workhorse function, weather download, and we download that, and we're really only interested in anything after September. And in this case, we're actually interested in hourly data, because we run that sort of similar high resolution that we got with the hydrometric data. And this last argument is just quiet equals true, because weather DL has some stuff that it prints, and it just made it easier to fit onto the slide here. And so you get all these variables. You get the pressure, the relative humidity, temperature, et cetera, et cetera. And what I thought would be interesting is to just plot the wind speed, which is actually not even visible here. It got cut off by the slide. Sorry, my fault. But if we do that, we plot the wind speed. So that's on the left-hand axis, and then we've got date, and then this Malay Falls just happened to not have any data. It got plotted automatically, but didn't have any data for that period. But you can similarly see some pretty significant winds, and if anyone followed it, it was a fairly terrible situation for a bunch of folks in Nova Scotia. But you can see these high winds that are coming out in these weather stations. And again, we've stayed in R completely. And I mean, what's interesting is that this is the date provided by NOAA when it was over, and it's obviously a little bit incorrect, because we've got these high resolution hourly data that are showing peaks before when it actually hit. Might also due to some of the spatial variability of where the stations were. But the whole point here is that we've stayed in R this entire time, and we've managed to pull in this data. And you could have been doing this on September 8th, looking at this data almost in real time to provide that sort of these conditions for what is pretty huge physical event. Okay, so maybe I'll pause there. We're doing okay for time. I'll pause there.
Yeah,
Does anyone have any questions about that? And again, the code is available and it should be self-contained. People should be able to run it.
yeah. We do have quite a few questions here, Sam. I'll go through a few of them here. Leftover question from a while ago that I missed. Is there an R package for analyzing IDF or intention uh, IDF curves?
I don't know. I mean, so I don't know, but I will show you a place where I think we've curated a really high quality collection of our packages relating to hydrologic and meteorological analysis, and maybe just leave it there. So I don't know though.
Yeah, okay. And then another question, because we saw WeatherCan being used to download hourly data. Can the same be done with HiDDAT to extract hourly data?
So it can, so right now, so I'll just back it up. So this real-time function right here, real-time DD. So everything's basically split into two paths. Either you access the data by HiDAT, which has this validation process and data gets published on a quarterly basis, or you can use this real-time data to pull the last 30 days of any station in Canada that has real-time capabilities, which are, the vast majority now are do have real-time capabilities, but it only goes back. So a limitation is only goes back 30 days, and that's just that's what's provided by Environment Canada right now.
And on that note,
sorry, and then
yeah,
I mean, you can aggregate this over hourly. So this is like 5-minute data, and that's not standard. Some stations are 15 minutes. There is the ones that are collected on an hourly basis. That's a separate thing. It's relatively easy to do in R, but you're right now this is just provided as the raw sort of 5-minute interval data.
so that does lead into another question, which is the restriction for real-time data. And you mentioned that's 30 days. Is that true for WeatherCan and TidyHiDAT?
No. So no. WeatherCan is able to access a much broader swath of data. You can go way back. You might run into, if you try and request like a ton of data, like if you try and request 1,000 stations for the last 100 years, like all that data has to come over the web, and then it also has to all fit in memory. So you're gonna bump up into some restrictions on that perspective, but strictly speaking, there isn't that limit available, or isn't that limit present for WeatherCan, whereas there is for TidyHiDAT right now.
And then another question about, can you expand on obtaining Hurricane Dorian's path from NOAA?
Right. So, it took about, it's amazing, right? Like it took about 4 minutes of searching, just looking for a shapefile of Hurricane Dorian path, and it was available. And it's just a shapefile that, I download directly in R and unzip and read in the shapefile in R, and then do the spatial analysis. There is a really, really cool package though called RNOAA. So because Hurricane, I wanted to use a relevant current example, so I kind of had to grab that one separately, but there's a package called RNOAA which does some similar things to what we're talking about here, and one of them is a storms database, and so you can access directly in R all the storm data that NOAA has, and you can really do quite a lot. It was a giant rabbit hole for me actually, because I just ended up looking at all this storms data, but that's also in that list of hydrologic and meteorologic data packages that I was mentioning earlier, that I'll link to at the end of this.
And then the last question, which I think I know the answer to, in that everything is on GitHub, but can you share the scripts for these nice plots?
Yeah, absolutely. So everything will be on GitHub, and there'll be the last link, and then I can pop a link right at the end. I'll make sure to pop a link in the chat, and then folks, but it's in the GitHub GitHub for TidyHiDAT. That's where it is, but I'll pop that link in there.
Perfect. Okay, you can continue, I think.
Great. So something that I'm not going to go into too deeply, but I just want to illustrate what else is available in R, and I'll just focus on this one package. Base R plotting is like a very functional approach to plotting. But there's this other package that came out about 10 years ago called ggplot2, and this is like just an absolute, just fantastic package for doing plots in a very sort of, once you kind of wrap your brain around it, a very intuitive way and a very like efficient way. So you don't need that much code to really do some really nice plots. So this is just an example of how we can get from something in HIDAT to a plot that really gives us some insight pretty quickly. So what I've done here is I've just taken HIDAT stations, and then I've got an argument for the province, territory, state, or location. So this is like the jurisdiction. And then there's just a little short, like a convenience function where if you say Canada, it just gives you all the Canadian stations. And say I'm interested in sort of drainage areas that are under 10,000 square kilometers. And so these are these Canada stations. This is, you know, something that we've kind of done already. And then I'm interested in comparing discontinued versus active stations. And what I can do is I can map that variable to the fill of some plots, and then I want to map it as like a density plot, which is sort of like a continuous smoothed out histogram, and it scales things so that you can compare the distribution of variables of different magnitude. And then I've just got some panels organized by the provinces, and then I've got some sort of right here. Oh, my code's a little bit wrong actually, but anyways, this is the labels here. And so you can look at this plot, right? So that was a relatively small amount of code, and what we have on the bottom axis is the gross drainage area, and then on the left axis is just the density. So think about these as smooth histograms for plots under 10,000. What you can really see is that in the discontinued, so that's the yellow, you can see that we're really monitoring larger watersheds over time. And so the active ones are the purple, and the yellow ones are the discontinued. And you can really see that gap in many provinces is sort of trending towards monitoring larger watersheds. But so right away, you're like pretty quick and you're able to derive some insight from that. So I just want to show you that ggplot2 is also very well documented. There's a couple great books out there. And if you're kind of sitting down for the first time in R, and you're like, I'd like to take advantage of some of these plotting capabilities, I'd highly recommend to sort of dedicate your limited time to learning ggplot2. So that's kind of the point of me saying this. So it can be super hard. Like this, a lot of the stuff, you know, it's can be really struggling. You can really struggle with it. You can bang your head against the wall. And so there is sort of ways that we can ask questions better. And this is kind of what I want to spend the last part of this webinar focusing on, and to also talk about some resources that you might be able to ask questions at. And so, you know, there's a community site around the RStudio. There's web server or web mailing lists for the R project itself. And then there's something called Stack Overflow, which people probably have heard about, which is just a place where you can ask questions about code. And these are good resources to use. Now, okay, asking a question is an absolute art in R, and I'm going to sort of try and show you a way to ask a question where somebody can really quickly help you. And I'm going to make use of this package called the REPREX package, which stands for reproducible example. Because if somebody, so R is this amazing community with these incredibly helpful people. And if somebody is able to take your code and immediately run it, and you've got an issue, they're much more likely to be able to help you if they can run your code. And so REPREX sort of tries to help with this. So I'm going to try and demonstrate this. So say you're interested and you've come to this webinar and you wanted to do something with tidyHIDAT, and you also want to do something with dplyr. Okay, so you've got your script and you've loaded these up and you're happy with this, and then you're gonna go, say you're up in the Yukon and you only want the Yukon stations, but then again you're you're interested in, like, maybe you're interested in, you know, something like this, where you're only interested in the active stations, and you're trying this, and it's like, it's just not working. You're like, what's going on? What's going on? What you can do is, okay, you install the Reprex package just in the other ways that we've looked at. And what it does is it adds a little thing in here up in this add-ins package. So if you take your code and you highlight it, then you go to the add-ins package and you scroll down, and you've got something. And again, this is all very well documented on the web, but just an example. So you click this Reprex selection, right? What happens is it's rendering the Reprex. It takes a half second, and it adds this little bit to your keyboard, or it adds it down here to the viewer, but it also adds it on the clipboard. Okay. And then say you take to Stack Overflow and you want to ask a question. So, tidy HIDAT issue, whatever. Some text describing, okay, spell my problem, right? And then remember, I've got something on my clipboard, so I type that in right like that. And what this does is it gives the whole bit right here formatted very nicely, and this whole script. And so I can take this self-contained script and say I was reading, looking this, answering this question. And of course, the problem is that there's no, we misspelled the variable that we want to subset by, so HY status. So Reprex now allows us to format it really nicely for some of these common question answering sites. But what it forces us to do is it forces us to create a self-contained problem. So we're able to, the error message right here, hide status not found. It forces us to create a reproducible example that somebody can really quickly answer for you. I'm not sure if that was clear, but using the Reprex package, and the nice thing is that once you conform it to how the Reprex package works, half the time at least you kind of solve the problem yourself. And so I would really encourage folks to, if they're looking, this is maybe just like one step above beginner, but if you're having problems, try and put it in a Reprex format, and then that ensures it's reproducible for whoever you're asking the problem or asking the question of. So both these are open source projects. Tidy HIDAT, WeatherCan, all the source code is available online. They're openly developed on GitHub, which is a code sharing platform. I'm sure people probably have heard of this. And here's some links to the actual websites, or the code websites. So Tidy HIDAT, all its code is contained right here. I've got a README that sort of gives you some basic information on how it goes. Similar with WeatherCan, some basic information. That's like the code side to things. And any contribution helps. So if you feel like you're using Tidy HIDAT or WeatherCan and something doesn't make sense, this is a great place to ask questions or to report potential bugs, where you do have to sign up for a GitHub account, but then you can put in issues where you could do that Reprex, you can report an issue, you can just be like, I'm having trouble. This is a great place to do that, is in the issues of both of these packages. Or you might have like a feature request, or you might have like a bug fix itself. So like that's the perfect scenario where you found a bug and you've also found a fix. And so there's ways on GitHub to contribute code, and then you become part of the project. And we've, for both packages, we've had folks that have used it, found issues, found bugs, fixed them, and submitted that code. And that's sort of, how the way open source really works. And, it doesn't have to be code either. It can be documentation that's like just as valuable. And so if anyone's interested in, writing an article about it or anything like this, we'd just like be super grateful for any other perspective on it at all. So yeah, some ways that you can contribute. You can, one thing you can do is you can cite it as you would with a paper. You can write some documentation. You can write a vignette. You can use the package. It just helps just to use the packages and find bugs and find inconsistencies and find ways that it maybe doesn't work as exactly as it should. For maybe like a little more advanced ideas, Tidy Hidat or Hidat itself is a SQLite, and so there is ways that one could write SQL code to leverage the database and really quickly do some efficient analysis. So that's like a kind of a pie in the sky idea, but it's something that one could do to efficiently use that data. And then WeatherCan probably could use some print methods similar to Tidy Hidat, where it says, data was downloaded on this date, here's the range, here's some stations that you might need. So that's just some general ideas and there's other things that probably could be done as well. So again, these are software that get used and people spend a lot of time on them, and both of them have been peer reviewed. And so you can cite these as you would any other paper or any other effort directly in your in the papers that you write. And the advantage of this is that it sort of helps justify and helps confirm that folks are using these, and it's really useful as metrics for how valuable these projects are to the sort of community at large. And I mentioned they're peer reviewed, so both of these packages are part of a really great network of R packages that really focus on open science and really focus on reusable tools, and that's this organization called R Open Sci. So these packages were peer reviewed in the open by experts in both fields. Tidy Hidat was reviewed by 2 USGS scientists, and I can't remember what WeatherCan was done peer reviewed by, but both of these are part of this network, and this R Open Sci is a really, really, really great organization with a really welcoming community of folks that are just really passionate about open science. And so both of these packages contribute to that larger effort as well. So lastly, so here's some helpful links. So if you are today just hearing about R for the first time, I hope your head's not spinning too much, but if it is, the place to start I would really recommend is this one right up the top. It's this book online. You can also buy it, and I certainly would encourage you to buy it, but it's also all available for free online, and it's called R for Data Science, and it's a great resource to start out with. It just is a great place as a great entry point into R. Really accessible, really great writing, really useful. The getting started with Tidy Hidat and WeatherCan, I opened this before, but these are these websites that kind of have articles, introduction to using Tidy Hidat, 2 examples of using Tidy Hidat, some stuff I've written and other people have written to try and get around this. And then similarly, Steffi has this WeatherCan site, which is got lots of information on here and a good place to sort of poke around if you're interested in using the packages. I mentioned this right here. This is the hydrology task view. So this is on the central repository for our packages is a curated list of packages that really work in this space. And so you can, there's Tidy Hidat, but there's a ton of stuff, and we've tried to organize them into sort of hydrologic sources, meteorologic data, and then there's some data tidying, but there's also some really exciting modeling packages that are going on, and folks might find those interesting. And there's a lot of actually interesting work happening in the space in R where you might want to leverage some of these, because ultimately it's not super exciting to bring the data in. It provides an easier mechanism, but really you get the data in and then it's so what? And so you obviously want to do something with that data at some point. And this is probably an on-ramp to sort of learn about some of those packages. Here's a link to R Open Sci. It's a great thing to follow if you're interested in the R community. They publish really great articles. They also have really interesting calls regularly, curated, presenting interesting packages, and it's sort of a good entry point into some really neat things that are happening in our community. And then I just put this here so we all end up still having to work in Excel. I'm sort of advocating for this reproducible approach, but we do often work in Excel. And if you're working outside of ECCC data sources, you're gonna have to work in Excel. And so this is just I just try to say this to everybody. It's a great article where folks have identified some really good principles to organization in spreadsheets. So that's just kind of like something that's pretty good. So yeah, if you get into this, your only friend's gonna be a computer because you got to spend a lot of time at a computer. But I promise it's fun. And so yeah, I'll put these links right here into the chat, and folks can go there. Did that come through? I think so. Yeah, great. So these two links will link to the slides, and then yeah. So anyways, we've got 7 minutes for some questions now, I guess.
Yeah. If there are any last minute questions, then now's a good time to bring them in. Otherwise, everyone's muted, but silent round of applause for Sam. This is a volunteer presentation, and I think it's pretty evident that this is a good source of information, and hopefully it was helpful for everybody. I will take a minute just to mention that there are a lot of links that I've been sending throughout the webinar and the chat, so feel free to take a look at those and favorite them as you need to. And a quick plug for the hydrology group as well. So it's also an open source project available on GitHub, and it's a good group in terms of networking and lots of other resources. There's a link to the GreyJay project, which has links to lots of resources for hydrology in Canada, including the hydrology package, as well as the Tidy HYDAT and WeatherCan and a number of other packages as well. I think that's about it. Maybe we'll give it 1 minute here in case there's any other questions or comments to pass on. I said I would pass this on afterwards, but there is a comment here, Sam, about a suggestion about data coming in GRIB format for a lot of climate models. So having some functionality to read in GRIB files would be helpful. Do you know if there's a way to do that currently?
Yes and no. So that's like a reasonably challenging topic. There certainly is the functionality to read GRIB files, but I would think that would be like so I think that would be probably an additional package. That would be like WeatherCan dot models or something like that. I think it's good to sort of keep these things reasonably constrained. But I mean, obviously that would be great. And the GRIB, I haven't dealt a ton with GRIB files, but I know it is possible in R.
Excellent. I don't see any other questions popping up, so maybe I'll just iterate one more time that the link to the newsletter for CSHS Hydrology group for more events like this is in the chat window, so find that and sign up if you're interested. These webinars have been pretty successful so far, so thanks again to Sam for putting on this one, and we will have some other webinars in the future on some other topics. There will be a post-webinar survey that I'll try to send around afterwards. There's been Sarah Fruin, who's the organizer for CWRA, is moving on to a new role, so there may be some technical difficulties in setting up communications, but hopefully I won't pose too much of a challenge. So we'll get that survey out afterwards and try to get some feedback on the strengths and weaknesses maybe of this webinar and what to do for the next ones. And we'll try to do these webinars every few months. So if you do have some ideas about what to do in future topics, feel free to pass that along to us as well. Yeah, well, maybe one more time, thanks again, Sam. Any closing comments?
No, just feel free to reach out if anything is doesn't make sense or is confusing, which I'm sure there are plenty.
All right, well, yeah, thanks again. I'll keep this webinar open just for another minute or two, just in case people need to copy the links. And otherwise, yeah, a few comments. Thanks, Sam. So thanks for putting this on, and we'll looking forward to the next webinar.
Yeah, thanks for having me. It's any chance to talk about R, I'm pretty excited.
Perfect. Yeah.
Thanks, everybody.
Okay, thank you.